39 comments. Photo by Ruvim Noga on Unsplash. Recent posts. Secure NTP with NTS. Incremental backup with Butterfly Backup. Web of Trust, Part 2, Tutorial. Fedora 33 switches the default DNS resolver to systemd resolved. In simple terms, this means that systemd resolved will run as a daemon. All programs wanting to translate domain names to network addresses will talk to it. This replaces the current default lookup mechanism, where each program individually talks to remote servers, and there is no shared cache. If necessary, systemd resolved will contact remote DNS servers. Systemd resolved is a stub resolver. It doesn't resolve all names itself, by starting at the root of the DNS hierarchy, and going down label by label, but forwards the queries to a remote server. A single daemon handling name lookups provides significant benefits. The daemon caches answers, which speeds answers for frequently used names. The daemon remembers which servers are non-responsive, while previously each program would have to figure this out on its own after a timeout. Individual programs only talk to the daemon over a local transport, and are more isolated from the network. The daemon supports fancy rules which specify which name servers should be used for which domain names. In fact, the rest of this article is about those rules. Split DNS. Consider the scenario of a machine that is connected to two semi-trusted networks, Wi-Fi and Ethernet, and also has a VPN connection to your employer. Each of those three connections has its own network interface in the kernel. And there are multiple name servers. One from a DHCP lease from the Wi-Fi hotspot, two specified by the VPN, and controlled by your employer, plus some additional manually configured name servers. Routing is the process of deciding which servers to ask for a given domain name. Do not mistake this with the process of deciding where to send network packets, which is called routing too. The network interface is king in systemd resolved. Systemd resolved first picks one or more interfaces, which are appropriate for a given name, and then queries one of the name servers attached to that interface. This is known as split DNS. There are two flavors of domains attached to a network interface, routing domains and search domains. They both specify that the given domain and any subdomains are appropriate for that interface. Search domains have the additional function that single label names are suffixed with that search domain before being resolved. For example, a lookup for server is treated as a lookup for server.example.com if the search domain is example.com. In systemd resolved config files, routing domains are prefixed with the tilde character. Specific example. Now consider a specific example. Your VPN interface ton0 has a search domain private.company.com and a routing domain company.com. If you ask for mail.private.company.com, it is matched by both domains, so this name would be routed to ton0. A request for www.company.com is matched by the second domain, and would also go to ton0. If you ask for www, in other words, if you specify a single label name without any dots, the difference between routing and search domains comes into play. Systemd resolved attempts to combine the single label name with the search domain, and tries to resolve www.private.company.com on ton0. If you have multiple interfaces with search domains, single label names are suffixed with all search domains and resolved in parallel. For multi-label names, no suffixing is done. Search and routing domains are used to route the name to the appropriate interface. The longest match wins. When there are multiple matches of the same length on different interfaces, they are resolved in parallel. A special case is when an interface has a routing domain, a tilde for a routing domain, and a dot for the root DNS label. Such an interface always matches any names, but with the shortest possible length. Any interface with a matching search or routing domain has higher priority, but the interface with is used for all other names. Finally, if no routing or search domains matched, the name is routed to all interfaces that have at least one name server attached. Lookup routing in systemd resolved. Domain routing. This seems fairly complex, partially because of the historic names which are confusing. In actual practice, it's not as complicated as it seems. To introspect a running system, use the resolvectal domain command. For example, $resolvectal domain global, link 4, WLP4S0. Link 18, hub 0 link 26, ton 0 redat.com. You can see that www would resolve as www.redat.com. Over ton 0. Anything ending with redat.com resolves over ton 0. Everything else would resolve over WLP4S0, the wireless interface. In particular, a multi-label name like www.foabar would resolve over WLP4S0, and most likely fail, because there is no foobar top-level domain yet. Server routing. Now that you know which interface or interfaces should be queried, the server or servers to query are easy to determine. Each interface has one or more name servers configured. Systemd resolved will send queries to the first of those. If the server is offline and the request times out, or if the server sends a syntactically invalid answer, which shouldn't happen with normal queries, but often becomes an issue when DNSSEC is enabled, systemd resolved switches to the next server on the list. It will use that second server as long as it keeps responding. All servers are used in a round-robin rotation. To introspect a running system, use the resolvectal DNS command. $resolvectal DNS global, link 4, WLP4S01922.168.1.18.8.4.8.8.8.8 link 18, hub 0 link 26, ton 010.45.248.1510.38.5.26. When combined with the previous listing, you know that for www.redat.com, systemd resolved will query 10.45.248.15 and, if it doesn't respond, 10.38.5.26. For www.google.com, systemd resolved will query 192.168.1.1 or the two Google servers 8.8.4.4 and 8.8.8.8. Differences from NSS-DNS. Before going further detail, you may ask how this differs from the previous default implementation, NSS-DNS. With NSS-DNS there is just one global list of up to 3 name servers, and a global list of search domains, specified as nameserver and search in /etc/resolve.conf. Each name to query is sent to the first name server. If it doesn't respond, the same query is sent to the second name server, and so on. Systemd resolved implements split DNS and remembers which servers are currently considered active. For single label names, the query is performed with each of the search domains suffixed. This is the same with systemd resolved. For multi-label names, a query for the unsuffixed name is performed first, and if that fails, a query for the name suffixed by each of the search domains in turn is performed. Systemd resolved doesn't do that last step, it only suffixes single-label names. A second difference is that with NSS-DNS, this module is loaded into each process. The process itself communicates with remote servers and implements the full DNS stack internally. With systemd resolved, the NSS resolve module is loaded into the process, but it only forwards the query to systemd resolved over a local transport, dbus, and doesn't do any work itself. The systemd resolved process is heavily sandboxed using systemd service features. The third difference is that with systemd resolved all state is dynamic, and can be queried and updated using dbus calls. This allows very strong integration with other daemons or graphical interfaces. Configuring systemd resolved. So far, this article talked about servers and the routing of domains without explaining how to configure them. Systemd resolved has a configuration file, /etc/systemd/resolve.conf, where you specify name servers with DNS equals and routing or search domains with domains equals, routing domains with, search domains without. This corresponds to the global lists in the two listings above. In this article's examples, both lists are empty. Most of the time configuration is attached to specific interfaces, and global configuration is not very useful. Interfaces come and go, and it isn't terribly smart to contact servers on an interface which is down. As soon as you create a VPN connection, you want to use the servers configured for that connection to resolve names, and as soon as the connection goes down, you want to stop. How does then systemd resolved acquire the configuration for each interface? This happens dynamically, with the network management service pushing this configuration over dbus into systemd resolved. The default in Fedora is Network Manager, and it has very good integration with systemd resolved. Alternatives like systemd's own systemd networked implement similar functionality. But the interface is open and other programs can do the appropriate dbus calls. Alternatively, resolvectl can be used for this, it is just a wrapper around the dbus API. Finally, resolveconf provides similar functionality, in a form compatible with a tool in Debian with the same name. Scenario: local connection more trusted than VPN. The important thing is that in the common scenario, systemd resolved follows the configuration specified by other tools, in particular Network Manager. So to understand how systemd resolved names, you need to see what Network Manager tells it to do. Normally NM will tell systemd resolved to use the name servers and search domains received in a DHCP lease on some interface. For example, look at the source of configuration for the two listings shown above. There are two connections, Parkinson Wi-Fi and Brno, BRQ, VPN. In the first panel DNS, automatic is enabled, which means that the DNS server received as part of the DHCP lease, 192.168.1.1, is passed to systemd resolved. Additionally, 8.8.4.4 and 8.8.8.8 are listed as alternative name servers. This configuration is useful if you want to resolve the names of other machines in the local network, which 192.168.1.1 provides. Unfortunately, the hotspot DNS server occasionally gets stuck, and the other two servers provide backup when that happens. The second panel is similar, but doesn't provide any special configuration. Network Manager combines routing domains for a given connection from DHCP, /RDNSS, and VPN, and finally manual configuration, and forward this to systemd resolved. This is the source of the search domain readat.com in the listing above. There is an important difference between the two interfaces though. In the second panel, use this connection only for resources on its network is checked. This tells Network Manager to tell systemd resolved to only use this interface for names under the search domain received as part of the lease, link 26, ton0 readat.com in the first listing above. In the first panel, this checkbox is unchecked, and Network Manager tells systemd resolved to use this interface for all other names, link 4, WLP4S0. This effectively means that the wireless connection is more trusted. Scenario: VPN more trusted than local network. In a different scenario, a VPN would be more trusted than the local network, and the domain routing configuration reversed. If a VPN without use this connection only for resources on its network is active, Network Manager tells systemd resolved to attach the default routing domain to this interface. After unchecking the checkbox and restarting the VPN connection. $resolvectl domain global, link 4, WLP4S0 link 18, hub 0 link 28, ton 0. Readat.com $resolvectl DNS global, link 4, WLP4S0 link 18, hub 0 link 28, ton 010.248.1510.38.5.26. Now all domain names are routed to the VPN. The network management daemon controls systemd resolved, and the user controls the network management daemon. Additional systemd resolved functionality. As mentioned before, systemd resolved provides a common name lookup mechanism for all programs running on the machine. Right now the effect is limited, shared resolver and cache, and split DNS, the lookup routing logic described above. Systemd Resolved provides additional resolution mechanisms beyond the traditional unicast DNS. These are the local resolution protocols multicast DNS and LLMNR, and an additional remote transport DNS over TLS. Fedora 33 does not enable multicast DNS and DNS over TLS in Systemd Resolved. Multicast DNS is implemented by NSS MDNS 4_minimal and Avahi. Future Fedora releases may enable these as the upstream project improves support. Implementing this all in a single daemon, which has runtime state allows smart behavior, DNS over TLS, may be enabled in opportunistic mode, with automatic fallback to classic DNS if the remote server does not support it. Without the daemon, which can contain complex logic and runtime state, this would be much harder. When enabled, those additional features will apply to all programs on the system. There is more to Systemd Resolved, in particular LLMNR and DNSSEC, which only received brief mention here. A future article will explore those subjects. Like this. For system administrators using software DNS networking network manager Systemd Resolved. Zbisic. 39 comments. Add comment. Mark. I haven't had good experiences with Systemd Resolved in the past, and am not too thrilled Fedora is moving to it. Hopefully it has improved significantly since I last used it. I've had a lot of issues resolving internal host names over a VPN, with split DNS, i.e., git.mycompany.com resolves to a server that redirects to our website publicly, but resolves to our internal GitHub server over the VPN. I've also had bad experiences with it leaking DNS queries all over the place. Also, RIPNs lookup. Systemd Resolved basically makes it useless. To troubleshoot DNS lookups now, you have to learn new Systemd-specific tools, and use other Systemd-specific tools to view Systemd Resolved logs. I can't help but feel Systemd Resolved is a solution in search of a problem. October 16, 2020. Reply. Zbisic. Issues resolving internal host names over a VPN, with split DNS, i.e., git.mycompany.com resolves to a server that redirects to our website publicly, but resolves to our internal GitHub server over the VPN. If you tell resolve to resolve. mycompany.com. On the VPN link, this should just work when the VPN is enabled. Make sure that the VPN connection A configures at least one DNS server, B configures a routing or search domain. I've also had bad experiences with it leaking DNS queries all over the place. I'm sad to hear that. In general, Resolved is about not leaking queries randomly, but using a very predictable rules for where to look up what. Maybe if you provide details, we could figure out what went wrong. Also, RIPNs lookup. You can give an explicit server name to nslookup. With split DNS you already had to this to some extent, since /etc/resolve.conf had no notion of split DNS and query routing. Hopefully tools like nslookup will just learn to look at /run/systemd/system/resolve.conf when appropriate. To troubleshoot DNS lookups now, you have to learn new Systemd-specific tools, and use other Systemd-specific tools to view Systemd Resolved logs. Well, it's 2020, you can't really admin a Linux machine without knowing journalctl. So the tool to look up logs is something that you probably already know quite well. October 16, 2020. Reply. Tomasz. Thanks for superb explanation of Systemd Resolved mystery. Winking face. October 16, 2020. Reply. Chris. How does this work together with Unbound? October 16, 2020. Reply. Specific. The functionality of both projects overlaps partially. Both provide a caching stub resolver with DNS validation. That is all Systemd Resolved is trying to do, while Unbound has additional functionality, in particular record filtering and a full recursive resolver. Systemd Resolved, on the other hand, provides a closer local implementation mechanism because it plugs directly into the NSS stack, while Unbound would be used with NSS DNS like a normal DNS server. So even though in theory both could be used in parallel, normally you would pick one or the other. October 16, 2020. Reply. Peter. Unbound is far superior to Systemd Resolved. If you need good DNSSEC support, where you can verify it's working, use Unbound. If you can use Unbound control, dynamic control is easy. Unbound host D or Delve don't work with Systemd Resolved. DNSSEC support is broken in Resolved, because authors don't like it. Just note sentence, often becomes an issue when DNSSEC is enabled. No explanation what it does. Instead OD proper negotiation, it blocks secure DNS by default. October 19, 2020. Reply. Venkata Subramani. Yes, this will definitely improve DNS resolution job. October 16, 2020. Reply. David both. So this appears to be client-side name resolution, and does not replace bind or other services of that nature for DNS servers. Is that correct? October 16, 2020. Reply. Specific. Yes. October 16, 2020. Reply. XM4N. Seems like Systemd is feature creeping on territories that it shouldn't be. If it is true that Systemd Resolve is the standard for Fedora 33, would there be a way to disable it? I rather go with resolve.conf. I don't need Systemd to be touching other components of my system. October 16, 2020. Reply. Specific. Systemd Resolved is part of the Systemd project, but it's separate binary, and a separate service from Systemd the Service Manager. See https://fedoraproject.org/wiki/changes/systemd resolved #opting_out_of_point2 fetc.resolve.conf_that_point_the_localhost_stub_resolver for instructions how to opt out. October 16, 2020. Reply. Jake. Using Fedora 33, the Network Manager Open Connect GNOME, that used to work without changing any configuration, has stopped working. This article helps me make some sense of why, but I'm struggling with what to do to fix it. I want my be able to resolve https://something.something.corp.local. Other distros that use Resolved have given me similar issues with various workarounds depending on the distro, to get .local addresses resolving. This is the most I've understood about what is happening, but as I said, I don't know the correct way to resolve this. Any help would be much appreciated. October 16, 2020. Reply. Alex D. Just disable the darn thing. Remove the /etc/resolve.conf file, which is symlinked to the Systemd stub resolver probably somewhere in /var/run/systemd. Configure Network Manager to update /etc/resolve.conf itself. Check this link, even if targeted for Ubuntu. The steps should be the same https://git.github.com/zoilamora/f7264fbb589f3f1b1fc2ca2c844c. October 16, 2020. Reply. Specific. .local is special because RFC 6762 reserves this domain for exclusive multicast DNS use. To make resolve it using the classic DNS using some local server, it needs to be declared as a search or routing domain. See https://www.freedesktop.org/software/systemd/man/systemdresolve.service.html #protocols%20 and %20 routing for a description of how this is supposed to work. October 16, 2020. Reply. Jake. #/bin/bash. /etc/network manager/dispatcher.d/90mycompanyvpn.sh. If $1 status $2 if $if == VPN 0, then case $2 and up, resolvectal domain VPN 0 mycompany.com corp local test.local, *, Using the above, https://www.techystalk.info/start-script-on-network-manager-successful-connection, and learning a little more about Network Manager and systemd resolved along the way, I am using this script to add the .local stuff to my domain roots. October 22, 2020. Reply. Anonymous. Seriously, people. Instead of so many negative comments by people who think it is cool to complain about every article, how about less sarcastic complaining and more learning something? Fedora Magazine. Org is not supposed to be an outlet for complainers, it is supposed to be a place to learn. It is impossible to learn when doing childish sarcastic complaining. At the very least, shut up till you try Fedora 33 for a few months then your opinion might count. October 16, 2020. Reply. Alexandra Dazardi. I agree, but systemd resolve did break OpenVPN VPN DNS resolution in general. We don't just disable things for fun. Anyhow, reading some bug reports seems to be a Network Manager systemd resolved interoperability when using the Network Manager OpenVPN plugin. October 17, 2020. Reply. Michael Catanzaro. In fact, when I proposed this systemd resolve change, my primary goal was to fix OpenVPN. I would never have proposed this change had I not noticed that my VPNs were not working properly without it. See https://fedoraproject.org/wiki/changes/systemd-resolve #benefit_to_Fedora. 70% of the benefit to Fedora section discusses split DNS with VPNs. The shared DNS cache is useful even for people who don't use VPNs, but otherwise all the benefit is for VPN users. I'm not aware of any complaints related to OpenVPN. The first I've heard about this problem is your comment here. We did have one bug report related to OpenConnect that took some time to solve, but it has been, resolved winking face, and we only know of one total affected user, so presumably it was fine for most everyone else. So if you're having trouble with OpenVPN, consider reporting a bug, because otherwise developers have no way to know there's a problem. October 22, 2020. Reply. Alex D. I can't really say it's a Fedora issue, but this Git repository, https://github.com/jonathanio/update-systemd-resolved, has the issues outlined. We do have a mix of distributions in our organization: Fedora, Ubuntu, Mint, OpenSUSE, Elementary, and maybe a couple of other. I do know this blog post is about Fedora 33, but all of the ones mentioned above use systemd resolved as the default DNS stub resolver, and we do have the issues described in the above-mentioned GitHub repository. Using the command line to connect to OpenVPN servers, and using that script as the up and down directives in the VPN configuration file does work as expected on all Linux variants. Do you know if there's a specific version of systemd and Network Manager that should have problems sorted out? October 23, 2020. Reply. Oded. Thanks for the great write-up. I have turned off Resolved on my system after fighting with it for a while, but that was 2 releases ago, Ubuntu. I'll try to re-enable it and see if my problems are now solved due to fixed, and my better understanding of what is going on. B. Your said 4 multi-label names, no suffixing is done. That seems incorrect, and if true, is a serious problem. I'd expect a resolver to look up all names, regardless of multi-label or not, and perform suffixing for names that get next domain results. This process, that is what DNS did as far as I know, makes it possible to write short names in my local network DNS stub resolver. For example, my router is simply named router on the network, and also have multi-label searchable names, like in your example. The network admin might specify the search domain as mycompany.com, and expect users to type www.private and www.public. October 17, 2020. Reply. Zbisic. I have turned off Resolved on my system after fighting with it for a while, but that was 2 releases ago, Ubuntu. Ubuntu sets up Resolved in a different fashion. Instead of using the NSS Resolve plugin to let processes communicate directly with Resolved over dbus, it configures Resolved as a server in /etc/resolve.conf, so that NSS DNS is still used. But because NSS DNS and /etc/resolve.conf have no idea about split DNS, the effects are different. NSS DNS just uses normal DNS protocol, while the dbus protocol allows additional metadata, so in some cases it can return smarter results. So please don't assume that the results with the Ubuntu setup will be the same as the Fedora setup. If some queries are routed to the wrong place, feel free to open a bug. October 17, 2020. Reply. Muayyad Saleh Al-Sadi. How to set caching features in systemd resolved. October 17, 2020. Reply. Zbisic. The cache is always on by default, and can be disabled with https://www.freedesktop.org/software/systemd/man/resolve.conf HTML #cache equals. The cache is flushed when links come and go, and the name routing logic is changes. October 19, 2020. Reply. Ticked off. Why does this not automatically update the DNS servers it has cached when you change them in Network Manager? I had to change NICs and this thing left me dead in the water, with no way to even search for a solution, because nothing in this stupid thing updates automatically. Also congratulations for killing Myth TV with this nonsense. Looking forward to the systemd Myth TV fix. October 17, 2020. Reply. Zbisic. Why does this not automatically update the DNS servers it has cached when you change them in Network Manager? Quoting the text above, how does then systemd resolved acquire the configuration for each interface? This happens dynamically, with the network management service pushing this configuration over dbus into systemd resolved. So the general answer is that this is up to Network Manager. More specifically, Network Manager will disable the old servers in systemd resolved when it takes the interface down, and add the new ones when bringing up the interface. This means that after name server configuration is changed in Network Manager config, the interface needs to be re-enabled for the config to take effect. Myth TV. I'm not at all familiar with Myth TV, but I'm sure any problems can be fixed, once the maintainers have been notified about the bug. October 19, 2020. Reply. Pyotr Dobrogost. I've been going through similar configuration, but using systemd networked instead of Network Manager. I described what should be done step by step in such a scenario in the question and answer, titled How to Configure systemd resolved and systemd networked to use local DNS server for resolving local domains and remote DNS server for remote domains. https://unix.stackexchange.com/q/442598/5355. Also for people using OpenVPN, but not using Network Manager, I highly recommend https://github.com/jonathanio/update-systemd-resolved as a way to update systemd resolved on VPN link going up/down. October 17, 2020. Reply. Nehemiah I. Dickers. No MDNS in Fedora 33? So no Avahi in Fedora 33? Why? October 18, 2020. Reply. Paul W. Fields. As the article states, multicast DNS is implemented by NSS MDNS 4_minimal and Avahi. These aren't implemented in systemd resolved, at least not yet, and in Fedora 33 they'll continue to be handled as they are now. In the future, if systemd resolved does implement MDNS, Fedora could consider changing the default handler. I also use MDNS, and it is working as usual on my local network from this Fedora 33 beta box. October 18, 2020. Reply. Michael Catanzaro. Well, systemd resolved actually does support MDNS, and we originally planned to use it for MDNS resolving while continuing to use Avahi for MDNS responding. But MDNS resolving was not working as expected out of the box. Avahi is more mature, so it seemed better to stick with that for now. October 22, 2020. Reply. Gregory Bartholomew. I find systemd resolved split DNS option to be very useful. I'm glad that Fedora is switching to it by default. It is especially useful in combination with systemd networked and WireGuard to route some non-public DNS queries over the encrypted WireGuard VPN. Below are my config files as an example for anyone who may want to try to do something similar. Again, I think this is a wonderful / invaluable feature. Kudos to Fedora for providing it. /etc/systemd #cat resolve.confd/custom.conf resolve DNS equals 8.8.8.8 DNS equals 8.8.4.4 fallback DNS equals domains equals LLMNR equals no multicast DNS equals no DNS over TLS equals yes densec equals allow downgrade /etc/systemd #cat network /20wg0.netdev netdev name equals wg0 kind equals WireGuard WireGuard private key equals XXX WireGuard peer public key equals YYY endpoint equals 146.163.0.1:9 allowed IPs equals 10.0.0.0/8,146.163.0.0/16 /etc/systemd #cat network /25wg0.network match name equals wg0 network link local addressing equals 0 domains equals siue.edu DNS over TLS equals no densec equals no DNS equals 146.163.252.126 DNS equals 146.163.252.127 address equals 172.16.0.1/16 address equals 172.17.0.1/16 address equals 172.18.0.1/16 root destination equals 10.0.0.0/8 gateway equals 172.16.255.254 root destination equals 146.163.0.0/16 gateway equals 172.17.255.254 root destination equals 192.168.0.0/16 gateway equals 172.18.255.254 /etc/systemd #cat network /80enp2s0.network match name equals ent2s0. Network, link local addressing equals 0, address equals 172.31.0.1/24, gateway equals 172.31.0.254. Route, destination equals 146.163.0.1, gateway equals 172.31.0.254. PS, I do find that there are a few things that Google's DNS servers don't seem to resolve, e.g. Amazon.com and Duolingo.com addresses. For the few things that I've found such problems with, I've been able to work around the issue by using Firefox's DO to connect to Next DNS. I use Chrome normally and switch to Firefox for the things that don't work with Chrome/Google DNS. October 18, 2020. Reply. Alex D. I'm sure it works well with Systemd networked. Unfortunately on the desktop we all use Network Manager, and from what I can see, these two don't have everything sorted out just yet. So before pushing Systemd resolved and Systemd networked, maybe the guys at Red Hat/Fedora, and Debian, and Canonical should have thought first resolving the issues with the interoperability, either fix Network Manager so that bugs like DNS leaking doesn't happen over VPN, domains that should be resolved over the VPN connection would work as expected and other similar issues, or make Network Manager a compatible GUI for Systemd networked, or just provide an alternative to Network Manager as desktop application for Systemd networked. I think these are the issues, not that Systemd, networked, resolved, are bad, but these were pushed without being tested enough, and they might even be working very well on a server where we do everything by editing configuration files, but not so much on the desktop. October 19, 2020. Reply. Zbigniew Jedziewski-Smek. The change in F33 has nothing to do with Systemd networked. It's not being pushed, it is still disabled by default. There is no plan to make Network Manager or something else a wrapper around Systemd networked. They have very different philosophy, so that's unlikely to be pursued. Also, the change in F33 is precisely about avoiding the situation where DNS leaking happens. This article didn't go into the details of this, but in the previous setup DNS leaks were essentially unavoidable because server priority depended on the order in which interfaces were brought up. The change page, https://fedoraproject.org/wiki/changes/systemd-resolve number sign split_DNS, describes this pretty well. The final rules of DNS resolution depend on the interaction between Systemd resolved, Systemd networked, when used, Network Manager plugins, VPN connection configuration, NSS module configuration, Avahi, etc. So it's likely that we will not get all the corner cases immediately correct. Enabling this in F33 has the goal of letting the developers find the cases that were not covered. So please report when something doesn't work, but in a way that allows us to fix things. Asserting that it's broken and, nameless, guys at Red Hat/Fedora, and Debian, and Canonical should have thought first, and so on is not helping. October 19, 2020. Reply. John Cash. Just for fun typed it in. Live user at localhost live, $resolvectal domain failed to get global data, could not activate remote peer. October 19, 2020. Reply. Paul W. Frields. Not sure what the issue is on the bootable live system you're testing on, but it works fine on my updated Fedora 33. Beta Plus system here. $resolvectal domain global, link 2, Eno 1. Link 3, CRC link 4, CRC nick link 5, Verber 0 link 6, Verber 0 nick. October 19, 2020. Reply. Sergey. Only 2 questions. 1, as far as I remembered Nsmask could also cache DNS records. 2. How does the Systemd resolved link to DNS over HTTP? October 19, 2020. Reply. Zbisik. As far as I remembered, Nsmask could also cache DNS records. Yes. Nsmask provides a lot of similar functionality. The way that integration with the rest of the system happens is different though. Resolved allows everything to be configured over DBus, which is good for desktop integration. Resolved also uses a custom NSS module so processes, which resolve names don't do it using a network protocol, but instead communicate over DBus or var link, a Unix socket, locally. This allows us to sandbox things better. How does the systemd resolved link to DNS over HTTP? Right now not at all. It supports DNS over TLS though. DO has been requested, https://github.com/systemd/issues/8639. I expect we'll add support in the not-too-distant future, but nobody seems to be working on that right now. October 19, 2020. Reply. Antonio Diaz. I'm giving systemd resolved a try, coming from an unbound installation, working flawless for my use case, and I'm trying to compensate on my station for a flawed VPN configuration on server side. I'm using a/etc/network manager/dispatcher.d script to run resolvectl DNS and resolvectl domain to add the DNS servers and domain that are behind the VPN connection. That is working, but I'm wondering if there is a better systemd resolved-ish way to solve that kind of problem. The VPN server do no send the DNS servers addresses nor the domains they serve. Congratulates for the great article by the way. October 19, 2020. Reply. Zbisic. NM allows DNS servers to be set per connection, even graphically, as shown in the example in the article, and NM will forward those settings to resolved. There is also support for search domains through command line/config file settings. So it should not be necessary to call resolvectl DNS or resolvectl domain. See https://wiki.gnome.org/projects/network manager/DNS for some more documentation. October 20, 2020. Reply. Antonio Diaz. Thanks. I will take a look into it. October 20, 2020. Reply. Leave a reply. Comment asterisk. Name asterisk. Email asterisk. Website. Notify me of follow-up comments by email. Notify me of new posts by email. This site uses Akismet to reduce spam. Learn how your comment data is processed. Fedora 32 is available now. Read the release announcement for all the details. Subscribe to Fedora magazine via email. Join 7,172 other subscribers. Subscribe. Contribute to the magazine. Fedora magazine is looking for contributors. Propose a new article. Become a writer. Become an editor. The opinions expressed on this website are those of each author, not of the author's employer or of Red Hat. Fedora magazine aspires to publish all content under a Creative Commons license, but may not be able to do so in all cases. You are responsible for ensuring that you have the necessary permission to reuse any work on this site. The Fedora logo is a trademark of Red Hat Incorporated terms and conditions.